All right, let's jump right in. Today we're going on a bit of a journey, tracing this really powerful idea from the very dawn of the web all the way to the future of quantum systems. And along the way, we're going to see the huge difference between just repeating the past and actually creating the future. This quote right here, it's from a landmark 1993 research paper, and it just nails a challenge that has gone into overdrive these last 3 decades. The idea is simple but profound. The world we build, well, it ends up rebuilding us. Back then, things felt pretty turbulent with the internet and globalization just taking off. But today, that turbulence has become a nonstop storm of data, of constant change, and just radical uncertainty. The maps we used to use, they're completely useless now. So yeah, let's picture it. We're in the early 90s. The internet is just starting to weave its web around the globe. Globalization is hitting the gas, and businesses are feeling everything start to shake. All the old, comfortable rules were starting to just break. A paper from 1993 by Dr. Yogesh Malhotra absolutely diagnosed the core of the problem. We were using these old maps, these outdated theories, to navigate a brand new, deeply interconnected world. And that growing gap between our models and what was actually happening, it was becoming seriously dangerous. So, to fix this, the paper offered a totally new way of looking at things, open systems theory. Basically, instead of seeing a company as this closed-off machine, the theory forces you to see it more like a living, breathing organism that has to interact with its environment to get energy and information, just to survive. And that brings us to the really critical insight here. It's not enough to just look inside your own organization or even at the deals you're making. To really survive and thrive, you have to understand the very fabric of the environment itself, that hidden web of connections that holds everything together. Now, this framework from that 93 paper really helps us map out the world. Check out that bottom right box, L22. This is the spot that's so critical but almost always ignored. It represents all the stuff happening within the environment, totally separate from your own company's actions. In that box, L222 is what's called the causal texture. That's the key to the whole thing. It's the hidden currents of change. If you can understand it, you can start to anticipate major shifts and actually act on the real causes of things, instead of just reacting to whatever pops up on the surface. Okay, so let's fast forward to today and see how this all connects. We've got incredible computing power now. We've got AI. But here's the big question. Are we actually using it to understand this causal texture, or are we just getting better and faster at staring into the rearview mirror? And what's just wild is how much that paper saw this coming. Get this, it actually predicted that the very technology we thought would solve the problem, information technology, would paradoxically make the environment even more turbulent and fast-paced. And, wasn't that spot on? And this slide just lays out the core conflict we're dealing with right now. Today's generative AI, it's a magician when it comes to correlation. It can scan massive libraries of things that have already happened and replicate the past. You can ask it to write a poem like Shakespeare and it'll do a decent job. But if you ask it to design a traffic system for a city on Mars, it's going to fail. Why? Because all its data is from Earth. It's completely lost in a truly new context. It's fundamentally stuck looking backward, right when we need to be creating a future that has never existed before. So, in a world where the future is definitely not just a repeat of the past, relying only on historical data is, well, it's a recipe for predictable and often catastrophic failure. We need a completely new approach, a forward-looking imperative. Any real solution for navigating the world today has to solve what we call the modern trilemma. See, it's not enough to just be fast or just be tough. Real success means achieving all three of these at the same time, being agile, being resilient, and being sustainable for the long haul. Well, the answer actually lies in taking that original idea from 1993 and letting it evolve. We have to make the leap from just observing the causal texture to actually building systems that can model it and navigate through it. And that brings us right to the cutting edge, where that 30-year-old idea is really taking root in a new way. The goal now is to build systems that truly think forward, systems that embody this idea of forward-looking causation. We're talking about systems designed for a world with not just dynamic change, but even adversarial uncertainty. This is where that original insight has led. We're now talking about these new theoretical systems, sometimes called quantum minds or QASNs. Now, think of them less like a library that only knows what's already been written, and more like a powerful simulation engine. They aren't designed to just rehash the past. They're built to model and test thousands of potential futures. This helps us find the absolute best path forward, even when the world is throwing completely unpredictable things at us. At the end of the day, this all comes back to a really deep truth from Einstein. Knowledge, that's our archive, it's the past. But imagination, our ability to model what could be, that's the engine that actually creates the future. Okay, so let's tie this all together. From that 1993 paper on causal textures all the way to the frontier of these new quantum systems, the fundamental lesson is exactly the same. We have to start prioritizing forward-looking creation over backward-looking analysis. Real innovation comes from understanding why things happen, not just copying what's happened before. Honestly, that's probably the most important strategic question of our time, and how we answer it is going to define everything that comes next. Thanks for joining me for this explainer.